Hi you guys. This is skill 12, application of exponential functions. So last class we learned how to graph them, and today we're going to learn more of like how to apply them. So go ahead and take out your notebook, wherever you're taking your notes. At the bottom of the screen here, it says the page number or the slide number, if that helps you. Using a calculator. So Alex should walk you through how to use a calculator. But go ahead and make sure that you are practicing this. You should get 0.786. It says round to the nearest thousands, so that's um tenths, hundredths, thousands. So 3 decimal places. This is what you should be getting when you round those. Okay, you're going to want to take this and copy this down. This is our basic system or formula for growth or decay. So A for both of them is always our initial amount. R is always our growth rate. It's often a percent, but we write as a decimal. And then X is how much time has passed, usually. So the thing I want you to add is 1 plus R here is always greater, not less than, no, it's always greater than 1. 1 minus R here is always less than 1. So that's how we know if something's growth or decay. So you want to make sure you copied this and wrote this down. So it says a study's done that shows the number of bacteria cells in a petri dish. Suppose the population size after T hours is given by the following equation. What is the initial? So number A is my initial. So that's going to be, I started with 26,000 or 2,600 cells. Does it represent growth or decay? So 1.05 is greater than 1, so it's growth. It says what percentage does the population change each year? So we're thinking 1 plus R equals 1.05. So we're trying to find this R value. I'm increasing by 0.05 or 5%. The value of a car is given by this equation where t is the years old. So find the initial value. Remember my A. Oh, it froze. So initial value is 25,900. And it wants to know the value amount after 12 years. So I want B of 12. If we had to predict, do we think the car is going to be worth more or less as time goes on? We're used to cars being worth less as time goes on. That's what we get when we put that in a calculator. So that rounds to, it says nearest dollars. Sorry. After 12 years, it should be worth this much. And we can assume that because this is less than 1, it's decay. Okay, so I'm going to give you guys a second to read this on your own. So it tells us about a forest, the size of the forest, and then it tells us how much it's decreased by 5.75% each year. Let T be the numbers of years since the study started. It wants us to write an equation in between y and t. So I know that I do y equals initial amount, whatever that is, and then this is decrease, so I'm going to use this equation. 1 minus r to the time t. So my initial amount is the size of the forest. I decreased by that. So my initial amount this as a decimal would simplify to that. So I use my variables y and t. As we talked about last lesson, a line that we are continually approaching but does not cross is considered our asymptote. So we're just reviewing that concept. My asymptote here is at -3. So it's at y equals -3. Here it's at y equals 1. It's kind of hard to see here, but it's there. So y equals 0. So we're going to keep this in mind as we go on. A company made a change in its advertising. Suppose the company's monthly revenue is modeled by the function below. So this is time and how much they get. What is the initial amount that they have? So this initial amount is what we started with at time 0. Oh. So it's going to be $20,000. And it's represented by, this is the y-intercept. So it's represented by the y-intercept. Over the first 10 months, so over this chunk, the revenue, has it increased or decreased? It has gone up, so it's increased. And where is our asymptote at? Our asymptote is at 100. And given this, which of these is true in terms of the asymptote? If it means that we cannot go over 100,000. So it will plateau at 100,000.